All right, friends, welcome to the Azure Data Fundamentals Workshop. My name is Will. I am our Azure specialist for Coding Dojo. I run all of the Azure workshops and materials, and it is my pleasure to walk through a workshop for the DP-900 certification. So this is a workshop for the data science cloud, Azure, so Microsoft's cloud data science DP-900 certification. So this workshop is designed and set up to help you prepare for that exam. And we're going to talk a lot more about that here in a bit. Before we do, I do want to go ahead and give you a couple things in chat. You will see this presentation. This is my presentation, so you won't be able to edit it. If you do want to edit it, there on the top left, you'll see not up here, not this guy, but actually on the document itself, you'll see a file. You just say make a copy of entire presentation. And then once you do that, you'll have your own copy. So that way, if you wanted to edit, if you wanted to add certain things, you totally can do that as well. A couple ground rules before we get started. First and foremost, teamwork makes the dream work. We're going to be doing things as a group and as a class together. You are going to be split into groups. It's not just a certification process where I talk the entire time. You'll be working with your fellow cohort mates or fellow, I guess, certification workshop mates. And so we just ask that you have good teamwork, have good communication, that you're humble, right? I don't know everything about the cloud. People in here might ask questions that you deem silly, but still having humility and recognizing people are just trying to learn. And that's, the goal of this. Since you guys have already graduated Coding Dojo, you're really familiar with the term of strength through struggle. There's going to be some of this stuff, especially if you didn't come from the data science track. There's going to be some of this stuff that's a little bit harder to comprehend, maybe with data, but we're going to walk through it. So if it is a little bit of a struggle, that's often where you actually are learning. So making sure, just recognizing, yeah, there might be a little bit of struggle, but it's actually a strength, and you will learn material a little bit more efficiently that way. And the last one is respect. Again, this has to do with your teamwork, your teammates, and then just with myself as I'm presenting. If you're in a place that's super loud, keeping your mic off on mute is just helpful. Or if somebody's talking, not interrupting them. Or if they say something that, again, you deem silly, not laughing or anything of that nature. Here's a little bit of housekeeping. We have from 9 to 12, we have our morning session. We're usually about 12 o'clock is a great time that we will stop. We're going to have an hour lunch break. And then I know that we had said from 9 to 5, but it's really about till 9 to 3. We'll have the afternoon session where we're going to do some stuff in groups. We're going to do some stuff in the morning too. And we have some breaks in between as well. So should be about 9 to 3. If you do have anything that is preventing you from staying, or if you have to leave and go pick up your kiddo, or, you can't get back to 1:30 because of something, that's okay. Just make sure you're communicating with me. On Zoom, there's a chat feature. If you press chat right above the message where you type, it says to, and then you can click that little drop down and then give me a specific message. And then just letting me know, hey, I have this issue, but I'll be right back. I'll be right back, or I won't be here till 1:30, something like that. In this workshop, we're going to learn about data concepts, stuff that you guys are likely familiar with, relational and non-relational databases. We're going to see how that is in the cloud, and specifically how there are different data services with Microsoft Azure. So Microsoft's cloud and what the specific services or the specific capabilities of their cloud, what they offer. And so after this, you can take the exam, the DP-900 exam, and get certified. Certification lasts for 2 years, and it's a really great thing to showcase on your resume, on your LinkedIn profile, on social media, specifically on your resume and your LinkedIn profile, because when recruiters see that you are certified in Azure, it lets them know, hey, this person knows about the cloud, they know about data in the cloud, and it sort of sets you apart as they're looking, or if a automated system is going through your resume, which most resumes are read from like an AI. Seeing keywords like Azure and having this certification is a thing that might put you in the next stage side versus skipping over your resume idea. And in these slides, you can see here's a source that there's an increased potential for Azure. Azure is the second largest cloud provider right behind AWS, but they have the largest amount of not data structures, sorry, like data warehouses, where they have the most reach globally, which is awesome. And again, today is to prepare for our Azure Data Fundamentals certification. And these are the things we'll learn: how to work with data in the cloud. So again, the specific offerings that Azure has and the different types of data and how those differ. After this, you will get a discount where at the end, if you wait until the end of the workshop, you'll receive a 50% off voucher toward the Microsoft Azure DP-900 certification exam. Just note that this is a $50 savings. This is not a 50% off coupon. It does work for any certification, so it's not tied directly to the DP-900, but other certifications do cost more than $100. And so if you do want to use your coupon towards one of those certifications, again, it's not going to take 50% off a $200 one. It's just going to take $50. So the value is $50. You can apply it to whichever certification you want. You cannot stack them though. So if you've gone to all three of our workshops, you can't like do all three. But again, it's 50% off because the actual workshop costs $100 and this is a $50 savings. This is what it'll look like. You take the certification exam. This is the badge that you get that says you are certified. Again, the certification does last for 2 years. And so it's a great thing. You can have it for a while, for 2 years, and then you can go get recertified if that's where you find yourself. If that's something that your company uses or something your company desires, that's something that you can get recertified in the next 2 years. A little bit about the exam. It's 90 minutes is how long you have to take it. And it's anywhere from 50 to 60 questions, typically around 55. It is proctored, meaning that somebody watches you do the exam and to make sure that you're not cheating. And therefore, to have somebody scheduled, you do have to schedule in advance. The idea behind the proctored exam is it's not something that you can Google and look up and use your notes, which actually gives it validity, right? It shows that if you are certified, you do know this material just off the top of your head, not that you can Google and find, the information on the web. Now that is a great skill to have, but having this certification does prove, no, this person actually knows how data is handled in the cloud or actually knows how the cloud works versus this person can figure out. And so that's what gives the certification itself validity. This is what the format of the exam looks like. It's really the core, and this is what today's going to be primarily on. We're going to tailor it to where we've got core data concepts is 15 to 20%. Those are things we're going to learn: relational, non-relational data. We're going to learn how to work with relational data in Azure and non-relational data in Azure. And then at the end, so this afternoon, we're going to look at the analytics workload for Azure. Cool. So just wanted to show you, this is what the Learn platform looks like. So if you did want to look at that, I'll send that here. This is where the bulk of the material is coming from. Now we've taken the exams and said, okay, from our experience on the exam, these are the things that you need to know, and siphoned through the material and decided what was good and what was not really necessary for the exam. But this is the collection of data. So if you were to say this part, let's get started, you could sign in, track how much you have learned, and then you can see all these different concepts. So, okay, this part is a module that's called Explore Data Concepts. And then you can identify, this is a 10-minute read, this is 9 minutes, 3 minutes, 1 minute, 1 minute. And so you can even see at the beginning, oh, I've got an extra 30 minutes. I'm going to knock out a module and just learn about that. Again, that's the point of this entire certification workshop, is to make you familiar with those to where your studying for the actual certification is much of a lighter load because you already have a lot of these foundational pieces. And again, this is just a visual for my visual learners out there. This is a visual representation of what the learning path for this data fundamental certification looks like. Just really sort of ramping out the different things that I have already stated as part of the exam. Here is, again, those schedule and resources. So if you did want to look at this material, you can click this, click any of these links, and these links do take you to different pieces. So if you want to learn about core data concepts, you can click that here: relational data concepts, non-relational, and analytics. So data warehousing. This morning, here's our tentative agenda. Sometimes we get done with things earlier rather than later. And then, it can ebb and flow. A break might be 15 minutes early or 15 minutes later. If this doesn't work with you, just feel free to let me know. And we can, again, if you're like, oh, I need 15 minutes for a work call or something at 10:30, but we get done at 10:15 and we're coming back, just again, communicate with me. As long as you're here for the majority of the workshop, I will allow you to, get a certification coupon. If you don't stay, if you only stay for half, or if you aren't like going in groups or anything, that's where we can have a conversation about a coupon. But again, I'm not like trying to be the gatekeeper on coupon codes. I want you guys to go out there and get certified. So again, communication with me is key for helping me understand and helping me know. So this is what it'll look like today. And you don't have to do this, but there is a study guide here. I'll put this in the chat. Oops. This is not necessary. It's not something you have to do. It's just a tool that we've created that if you want to do this, if you like a way to sort of keep track of data, keep track of certain things, this is a study guide that you can have. Again, you can fill it out and make it whatever you want. In order for you to edit it though, this is my copy. You won't be able to edit this. You just go to File, make a copy. When you make a copy, it's going to make a copy in your cloud, and then you can edit it and you can do all sorts of things to it. So again, this is my copy. So make sure you can file, make a copy. And of course, I'm glad to provide this for you. And there's different readings and different pieces. If you want this relational data, if you're really struggling with a concept, you can use this. And then we did leave certain pieces. That way you can write your own questions if that's how you study most effectively. Okay, any questions on what we've talked about? Any questions on what we've done? Great. Well, let's jump in. Okay, so from the basics, first of all, I've been using this word Azure and Microsoft Azure, but what is Azure? Azure is, according to Wikipedia, is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers. So these data centers are basically big buildings that have servers and computers that allow us to do stuff. We can put our website on a server. If you guys attempted the black belt in the web development portion, you logged into an AWS server and you put your code up on the server. That way anybody could go and view it, right? You had this IP address, you gave it to your instructor, and then your instructor could go and then see your belt exam. Same sort of thing here. This data center is the same idea. It's a server. It's a building of servers that is all connected, right? To where I can put something up. I can host it in the US, or I can host it in India or Australia or the UK or Europe somewhere. And then my people can use and log into that server and do whatever my application allows it to do. I have other things I can put on a server rather than just applications, databases, anything that I need can be put on these servers, which is what we call the cloud, right? It's not really in the air yet. I think Elon Musk is probably going to get us there, but right now they are just buildings that we call the quote unquote cloud that are interconnected. Now, Microsoft does tout that they have the most data centers in the world. They're in all of the major countries and all the different areas. If you guys took the AZ-900 course, then you saw actually a map of all the data centers, and there's a lot of them. They're all over the world, and they're all connected. And so that's a big thing with Azure, is wherever your customers or wherever your users are, there's likely a data center close. That way you can create the best experience for them. So dealing with what is data? Well, data is a collection of facts such as numbers, descriptions, and observations used in decision-making, right? And data is all around us. Companies are collecting data, not just numbers and descriptions, but even like click rates and how long we view an image, right? You think about Instagram, they're taking all this biometric data constantly to see how long are they viewing this? What are they tapping on? What are the decisions that they're making? So that way we can stir them to, oh, this person really likes to see sports stuff on Instagram. Let's start showing them sports stuff on their feed. That idea. So data is a vast word for collecting different pieces of information and storing them in some way. And when we're dealing with data, there's really three types of data we have. We've got structured, semi-structured, and unstructured data. When we're talking about structured, we're thinking of tabular data that's represented by rows and columns in a database. Now, if you guys took Python or Java, you saw this, right? We used MySQL or SQLite if you did Django, or there's different tabular types of data, but it was tabular means that it's got rows and columns, right? Where the column represents sort of a category. You can see right here its name, and then the row is a specific entity of each product that has, and that's its name, its product number, its color, et cetera, et cetera. So that's what we call structured data. There's structure to it, right? Even one thing that's important to note is in structured data, every row must have the same amount of columns. So you can even see here that here's a table of customers, this top table, that all of them have to have a title. They all have to have a first name. They all have to have a middle name. And if there is not a middle name, looks like this is a middle initial, then the value is null, meaning nothing was provided, but null is still a value and every entity must have that value. Right. And that's a really big piece of structured data is there's structure to it, right? There's a blueprint of how this data must look. In semi-structured data, information that doesn't reside in a relational database still has some structure to it. Now, if you guys took the MERN stack where you had a Node.js sort of backend, then you're familiar with what we call a document, right? And this is a little bit more flexible. It's a key value pair base, right? But you can see here, these can be different. This is a customer. Great. So we have this document for customers where it's got a customer ID and this one has a name, but notice this one also has a title. The bottom document has a title and this one does not, right? Meaning that it is a little bit more elastic. It can change. It can have different sort of keys and have different values and still be considered a customer, right? So it doesn't have to follow the rigid formatting of structured data, right? So in this one, you have to have a middle name or you have to have a suffix. This one has a title, this one doesn't, and that's okay. It's semi-structured, but there's still some structure to it, right? There's still different, or there's still commonalities, there's still an ID, there's still things that sort of link them together. And then lastly would be what we call unstructured data. Unstructured data would be data that does not have a specific structure. And that's specifically things like audio and video files and binary data files where there's not structure. It's just, these are images, right? So these are a piece of data that we can't put in a document. We can't put in sort of a table, but instead the data in itself is just an image. That's what we call an unstructured piece of data. And so when we're dealing with these, we have these three different types, and there's two types of databases we're going to deal with. Our structured is our relational database. Again, that's your MySQL or your SQL, right? Or GraphQL or Postgres, right? These are these relational databases. Then we're dealing with non-relational databases, which is like your MongoDBs. And MongoDB can have your semi-structured or your unstructured. And so knowing that, okay, semi-structured data is connected to a non-relational database. Structured data, tabular data is a relational database. And by knowing that, when you're setting up your data and you're setting up your databases, it helps you make decisions of, am I going to need all this information always, or am I more flexible with the data that I'm collecting? If I'm more flexible, I might lean towards a MongoDB. If I want to be more rigid, then I can do a relational database, something like SQL. So dealing with relational databases, again, the information is held in tables, and a table contains rows, and each row represents a single instance of that entity. All rows of the table have the same columns, and some columns are used to maintain relationships. That's where this idea of the foreign keys, right? If we have a user table and an address table, and I have multiple users that have the same address, there's a foreign key that just relates this specific address to this specific user. So here I've got this idea of customers and products where C1 is Fred, P1 is a shirt. Then I've got this table that connects the two, right? Where I've got an order table and that associates my customer that bought a shirt. So Fred, C1, bought this product shirt, and they bought one of them. Oops, they bought one of them. And that's this order ID. So I'm able to connect multiple tables together in a relational database. So these are the main characteristics of a relational database. Is again, all the data is tabular. It is in rows and columns. And the entities are modeled as tables. So what we call this would be my customer table, my product table, my orders table. And each instance, again, represents an entity. This one represents one instance of an order. 1001 is another instance of an order. This Bert is an instance of my customer. It represents an entity, right? An instance of my customer. It just represents one customer. Each row represents one piece. Yeah, and then normalized tables relate to each other in a schema. So normalized means, again, taking that idea of a user and an address. Well, if multiple users have the same address, instead of storing the same information multiple times, I might make an address table and then just refer to it, right? And I just have the address stored one time, and then every user that lives there, I just connect and say, oh, it's this address at ID of 3 is related to this user. So it's a way that I can not store so much stuff and save some money in just like my sizing of my database. All rows in the same table have the same set of columns. Again, they all have to have the same things. No two rows can share the same primary key. That's our unique identifier, right? Table can have any number of rows. It can have 1, it can have 1,000,000. And then a foreign key is what we, again, talked about, is if we wanted to relate tables together, the foreign key is what relates them together. We talked about normalization, where you might sometimes break stuff out if you need. But just know that normalization you can, if you're trying to normalize, you don't have to, like, you can get sort of too normalized. You can get too granular with normalization and normalize everything, which actually then creates a harder process. So just being aware that there is a fine line of normalization. Just knowing that you can over normalize in a sense as well. So when we're dealing with these relational databases, an index is what helps you search for data in a table. So you can think of an index over a table like an index in the back of a book, right? And a book index contains a sorted set of references with the pages on which each reference occurs. So when you want to find a reference to an item in the book, you look through the index, right? You scroll to the back and you say, okay, I want to find where it talks about coffee. And so it'll tell you, especially like think of a big book for like school, then you might look and say like, well, where is coffee located, or where are all the pages that coffee is located? And then it will give you the page numbers where that is located. Same thing, idea of an index, right? An index is what allows you to search for data within a table. Now, on the actual exam, you don't need to know a ton of SQL. So if you guys took the Flask, you'll be just fine. If you guys took Flask for Python, you'll be super duper fine when it comes to SQL. But you will need to know a little bit. This idea of very simple things like select order ID and product ID from orders, where customer ID equals 1. If it says, I want to get all of the orders from customer of Fred, then I would have to do something like this, right? Where I'm saying select. When I say select, for those of you that were in the Django group, when I say select order ID, product ID, what I'm saying is I want to grab the columns of order ID and product ID from my orders tables. So when I say select, I'm selecting which columns I want. When I say from, I'm saying which table I want. So in this case, it's orders. And then I give some condition. I can, if I just ended my query right here, select from orders, what that's going to do is it's going to get me all order IDs and all product IDs. But then I can put some condition here where I say where customer ID equals C1. So I've got this customer ID piece. And so what this is going to do is it's going to get all of the orders and product IDs that my customer C1 that is associated to my customer C1 or Fred. So that is what you might have to do. You might have to do a little bit of drag and drop. So it might have like a select from where, or it might have you fill that in. I've seen it both ways on the exam, or I've heard of it both ways on the exam more so. To where it's just a very, very SQL, very, very, very light SQL query. You're not going to have to do like joins or anything like that, or any group bys or anything. It's just something very simple of, again, selecting which columns do you want to select, what table do you want to select it from, and if you have any sort of unique identifier, like you want a specific customers things, or you want a specific product, right? You want all the customers and order IDs from, P3, then you would say select customer ID, order ID from orders, because that's still your table, where product ID equals P3, something like that. Any questions on that specifically? So what we can do is, let's say that we have something that we're continuing to query multiple times, right? I can create what we call a view, and that's just a virtual table based on the result of a query. So I can create a view. If I'm going to refer to it back and like over and over and over again, then I can create a view, and it's basically like, okay, save this value or save this sort of query. So when I do this, this gives me all of the customer C1. Let's say I wanted to continue to refer back to that. I can actually create a view, and it's just sort of like a window on specific rows in an underlying table. Like I just wanted to create a view of all my customer one, because I want to track what they're buying or something of that nature. So that's what we call a view. So it's just like a snapshot of a result set of a query. So what I get back when I make a query. Cool. Any questions on relational databases? And just a side note, somebody I see on Zoom is the names under iPhone. If you could just, whoever iPhone is, just privately DM me. So that way, whenever I'm taking attendance and I know who to send the coupon code to, just send me your name. And that way I have it there. Everybody else is good. But whoever's on an iPhone, just kindly just private message me your name. Cool. A non-relational database. So in some situations, you might not have to be, you might not have the required knowledge of the structure of your data. So maybe you have data, but you don't know the structure that's set out in advance of it sort of arriving to your database. So in order for us to record it in a neat, or like I might not be able to set a neat set of rows and columns because I might not have that information available. So the common scenario there is where, so in that scenario is where we would use a non-relational database, right? I don't have this blueprint of how my data is going to come or what my data is supposed to look like. So I might use a non-relational database to be able to set it, and it might have some structure, but it's not so rigid, and it doesn't have to fit a super like rigid blueprint. So a key of these is that with a non-relational database, you can store data in a very flexible manner. Again, you don't have to have all the rows and columns. You don't have to have a lot of these similarities. They can be very similar, but you don't have to do that. And it doesn't impose sort of what we call a schema. A schema is the foundation. So non-relational databases don't impose a schema on data. So it's not a schema is like the blueprint, right? Of this is how it's supposed to look. Non-relational databases don't have that. So instead, they focus on the data itself and how to structure it, which means that you can store information in a natural format that mirrors the way you would consume, query, and use it. So it is a lot more flexible. They can be faster at times. MongoDB is just becoming sort of a monster of a database. So it's becoming like a SQL to where it's really, really popular. You can store information really, really fast and save it really, really fast. And we're going to see a little bit later on this idea of like ELT and ETL, and how we might want to store data that we're collecting really fast before we sort of clean it and do anything with it. And we can just retrieve it very, very quickly. So you might hear a non-relational database also be referred to as a NoSQL. So, oh, it's a NoSQL database. MongoDB is a NoSQL database. And that's basically saying the same thing as non-relational. And so there's actually some debate on whether it's intended to imply not SQL or not only SQL, because there are some non-relational databases that actually support a version of SQL. So SQL queries, that idea, adapted for documents rather than tables. So there's this great database that we're going to learn about, this service called Azure Cosmos DB, which is one of my favorite services that Azure has. I just think it's so flexible and awesome. But you can actually run SQL like queries on your data. And so that's where we sort of say like, okay, NoSQL should be not only SQL, because, because we've adapted and you have some sort of flexibility to where if you wanted to run a SQL like query on Cosmos DB, you can, even though Cosmos DB is a non-relational database. So you do have some more flexibility, and it's like a metamorphosis of both together. These are the four big types when we're talking about a NoSQL database, or not only SQL database, or non-relational database. There's key value, there's document, there's what we call a column family, and then we've got a graph. So when we're dealing with this key value database, it's often the quickest, and it is the simplest type of a non-relational database for inserting and querying data. Each data type, you can sort of think about it like a dictionary. Each data type, each data item, is in a key value store and has two elements, a key and its value. The key uniquely identifies the item and holds the data for the item, and items are stored in key order. So what that looks like is here, we've got this key value database where I've got this key of 5 A's, and then here's its value. It's in binary, right? So I've got this key. When I call this key, I get this value here, which is awesome. So those are great. Now, one of the downfalls of these is, if you guys have seen, we'll see in a document, right? I might say document 1 or this customer ID, I just want their name. I'm able to split all of my values and only get specific pieces of my retrieval, right? So one of the downfalls of a key value database is I can't split this value. When I call this key, I get everything. I'm not really able to chop it up. I'll sort of show you what I mean here in just a second when we get to documents, but that it's super fast. I can call this key and it gives me everything, but it gives me everything. I can't say I just want the first piece, or I just want this aspect of my data. I have to get everything there and then do something with it. So that is one of the downfalls of a key value database, is it sort of limits you in what you can do in your query types. When we're talking about key value databases, there's a service, and this is where sort of on the exam is specific to Azure. So a lot of the stuff that we're talking about is sort of generic, whether it's AWS or GCP, which is Google, or Azure. But then when we're talking about services, and part of the exam is what specifically does Azure offer in this regard versus like an AWS or a GCP. And so here we've got this Azure table storage and is an example of a key value store. So knowing that if I wanted to have and set up a key value store database on the cloud, Azure has something called a service called Azure Table Storage that allows me to do that. Now, and this is a big thing for the exam, Cosmos DB also implements a key value store using the table API. So when we're sort of thinking about this and going through these different databases, we're going to look at the specific service that offers it. And then Cosmos DB most often is going to be able to also provide that. The way I like to think about it is, this is if I just wanted a key value store, that's it. That's all I wanted. This is the a la carte, right? Azure Table Service is just that. If you go to a restaurant, you just want French fries, you can get them a la carte. Cosmos DB is the entire meal. It comes with things. Cosmos DB, if we're paying for that, gives you access to other things, but it also just includes Azure Table Storage. So we're going to see Cosmos DB sort of as the umbrella over most things, or most of the different types of databases. But if I wanted just the a la carte for a company reason, I don't need anything else, I just need a key value store, I can use Azure Table Service or Azure Table Storage. Any questions on that? Can I just put a 1 in the chat if that makes sense, and then a 0 if it doesn't? Perfect. Great, thank you. Wonderful. Okay, so now we're moving on to our document database. Now, if you guys did your MERN stack, then you're familiar with this, because that's how MongoDB stores stuff. So a document represents the opposite end of the not only SQL spectrum from a key value store. So in a document database, each document has a unique ID, right? So that's like its unique identifier, but the fields in the documents are transparent to the database management system. So document databases typically store data in JSON format, but they can also be encoded using other formats like XML, YAML, JSON, and BSON. So documents could even be stored as plain text. So there is a little bit of flexibility with the storage system. Now, typically you're going to be working with like JSON objects, right? In your document, that's the most popular way, but there are other formats if your company needs you to format it in a different way. This is what a document would look like, where I've got this key, right, of 1001. And then here's my document. I've got this ID right here, order items, et cetera, et cetera. This is stored in key value pairs. Now, this is what I was talking about from a difference with the key value storage and document storage is if I said key value storage and I wanted something at the key, I have to get everything, right? If this operated the same way, I'd say 1001 and it gives me this entire document. Customer ID, orders ID, quantity, cost, order date. But what's nice about a document storage type is I can say at key 1001, I just want the order date, right? And it gives me just that information. So it's a lot more flexible that way. You can sort of see like how my query could be different. Instead of me having to get everything and then siphon through all of that, what I can do is I can actually just take a sliver or a slice out of this entire document or this entire sort of dictionary. I can take a slice out of that and just get what I need. So I don't, I'm not limited to having to get everything. Now, again, when we're talking about the services, Cosmos DB implements a document database approach using its core SQL API. So it sounds a little bit unique because this is a non-relational database, but it's called a core SQL API. So Cosmos DB is, again, the service for documents, and documents are going to be super duper popular. Any questions on that? How document works? If you guys took MERN, I'm sure you're super familiar with that. And just knowing too that in these queries, although it is non-relational, the query might feel like a SQL API or a SQL query, right? There might be some structure that whenever we're structuring it, it might feel like it's SQL, but it is actually part of a non-relational database. Any questions? Am I going too fast? I feel like we're cruising, but. Okay, got 1 for no, we're chilling. Okay, great. A column family. Now, this is honestly can be the most confusing piece. Sorry, give me 1 second, guys. My coffee cup is leaking everywhere. Give me just 1 second. So sorry. Sorry about that, friends. My coffee cup was it was like a paper cup and it was just leaking through and spilling everywhere on my desk. So, okay, let's go back. So column family organizes data into rows and columns. Now, It looks very similar to a relational database, but in its simplest form, a column family database can appear similar to a relational database, at least conceptually. But the real power of the column family database lies in the denormalized approach to structuring sparse data. So you can sort of think about it this way, that it stores columns versus storing rows. In a relational database, we're storing all of these rows and it has the column structure. With a column family, it's just storing specific columns. So you can think of that as like holding tabular data comprising rows and columns, but you can divide the columns into groups known as a column family, where each column family holds a set of columns that are logically related together. So here, again, I might have information of a customer and addresses, right? That I want them to be the same, or some people might live at the same address. Looks like Mr. Walter Harp and Mark Hansen live together, right? So here I've got this row key, but I can take out the columns that I want associated together. So this customer info and this address info, I can take out those columns and create what we call a column family and say that these two are connected. So although it is a non-relational database, it does look like it's tabular. But the real key is it's divided by columns with my connection, not rows with my connection. Any questions on that? Cool. So from a service perspective, the most widely used column family database management system is an Apache Cassandra. So Apache Cassandra is the most used system. Cosmos DB does support the column family approach through the Cassandra API. So the way I like to think about it is Cassandra API, column family, they both start with a C. So if I have a question on which API, I sort of default to what does it start with for column, and you'll see the next one is graph. They both start with the same letter as their API. Now, a graph database enables you to store entities, but the main focus is on the relationships that these entities have with each other. So I have these specific entities of data. And with a graph, what I can actually do is instead of storing them in a certain, tabular way or through different columns, what I can do is actually identify the relationships between my entities. So the graph database stores two different types of information. It's called a node. So you can think of that as like an instance of that entity. If I have people, that's what we call a node. And then we have our edges, which is what specifies the relationship between my multiple pieces of nodes. So nodes and edges can both have properties that provide information about the node or edge, like columns in a table. But additionally, edges can have a direction indicating the nature of a relationship. So if we think about it, it's like we have a bunch of nodes. And if you guys ever did like a linked list, it's sort of that way. You can like visually see that, but it's just more of a graph. So it doesn't have to be like, linear. So it just sort of all these different data points can point to one another. And the best way to sort of explain that is would it be like an org chart where here I've got this node and it's got some pieces of information. In this case, it's just a name, where this node is my employee, Sarah. Sarah is associated and works in the head office. And there are 3 employees that report to Sarah. Max reports to Sarah. Alec reports to Sarah, and Anessa reports to Sarah. Within that, Anessa has a relationship with the Department of Manufacturing. Alec has a relationship with marketing, and Max has a relationship with sales. And Alec also has an employee named John who has a relationship with marketing. So this is what we call a graph, right? And so we see these different nodes and how they relate to one another. This is my node. You can think of these arrows as my edges. Again, Cosmos DB, you can sort of see the theme here. Cosmos DB does everything, but it does support graph databases using the Gremlin API. So again, graph, Gremlin, both start with a G. And Gremlin API is a standard language for creating and querying graphs. And so when I'm creating those, or I want to query and get some sort of information, maybe I want to see, all of the nodes associated with the marketing department, I can do that through the Gremlin API. Cool. Now we've talked about how we store data, but we want to talk about the different types and different processes we have when we have data. And we have two different types. So two different reasons why we store data. We have a transactional, and then we have an analytical. So transactional system records transactions. Seems, makes sense. Transaction is a small, discrete unit of work. So transactional systems are often high volume, it has to be accessible very, very quickly. And the work performed by transactional systems is often referred to as an OLTP, which is an online transactional processing. Can anybody think of like an example of a transactional system? You can come off mute and put it in the chat. Yeah, banking would be great. I mean, that makes a lot of sense, right? There's a ton of records and making transactions, or if you work in retail, exactly, to where people are buying and there's small little units of work. I'm tracking every piece of data of every order of how much the person did, their credit card, et cetera, et cetera. Yeah. So great job, guys. The second one would be analytical systems, and that's for querying data and gaining a bigger picture or view of the information held in the database. We want to capture raw data and use it to generate insights. An organization can use these insights to make business decisions. And things we might do with like an analytical system is data ingestion, data transformation, data querying, and data visualization. And so basically, using these analytical systems, I can take in some sort of data, right? Whether it's a critical device data, financial transactions, or point of sale data. What the analytical system will do is it will ingest my data into my database, do some sort of data transformation, which maybe I am creating new pieces of information with the data I have. I clean and transform it, and then I can do certain things to where I can make queries on my data. So if I wanted to do that with, like, I wanted to get all of my users who recently bought a t-shirt, or I can visualize it. And so maybe I'm forecasting, or I'm seeing financial decisions or what our sales did. And maybe I can visualize, oh, here's the regions that we had the highest amount of sales, or I can do some sort of visualization there. And when we're dealing with these analytical systems, there's really two approaches that we can do, or two different sort of processes we can do to load in and get all of this data. So the first one is ETL, which stands for extract, transform, and load. So the raw data is retrieved, so just raw data, and is transformed before being saved, right? So the extract, transform, and load steps can be performed as a continuous pipeline of operations. So basically what we do is we take this data, then we discard any sensitive data or data that we didn't need. Maybe it's like we have all this user data and I'm really only concerned with what they purchased. I don't need to know their birthday or anything like that. I can do some sort of transformation where I actually get rid of a bunch of stuff, right? I'd say, I don't need this. I just need, their transactions. And then what I do is I do that after it's cleaned and I've only taken the pieces that I need. I then load that in my database, right? That is called ETL. And that used to be the standard, but when the cloud came, everybody really has switched to the ELT. Now the government, because the government's usually like 10 years behind, they're like government systems, typically still use the ETL, but most companies now are moving to the ELT process instead. And that's extract, load, and transform. So that it changes this way. We have our raw data. And then now, instead of doing the cleaning and transforming, getting rid of the bits we don't need, we actually automatically put everything into the cloud, into a database. Then from that data, we do what we want, right? If I want to do some sort of complex processing, or if I want to just get certain queries or clean it and say, okay, from this data, let's go ahead and take all the data. Now I only want the user's transactions or whatever. And the reason is because it used to be really expensive in order for us to have and maintain a database, to have storage on the cloud or to have storage on-premise, which means basically all of our servers are where we are located in our building. We had to maintain those. If we needed more room, we had to buy more servers. Super high capital expenditure for that. So we had to sort of be cautious of how much we saved. You sort of think about it like on your iPhones, right? Or whatever phone you have. Back in the day, you know, you only had a certain amount of data. So you might have to, or a certain amount of storage where you had to go through your camera and delete all of your photos, right? Or delete enough stuff to make sure that you can get these songs on or something like that, right? So I had to really manage how much I had. Now, when we have the cloud, when we're dealing with our cloud, that issue is no longer, right? It is really, really cheap and really, really not difficult to just store everything. And the reason that that's a big deal is when we're dealing with this, we discard sensitive data. Maybe in 2 or 3 years, as my company grows, I really wish I would have had that data so I could see trends over the last couple of years. But I've already gotten rid of it in order to load that, right? And so this is a way that we can basically assure that we have every bit of information in case a couple of years down the road or later on our company flow changes or direction changes. And maybe I now do need some data that initially I was going to get rid of. By using the ELT, we have that all loaded on different ways and different things to where I'm not losing any sort of data, right? My data is not being lost. I'm not getting rid of something that later on I'm going to need because it's cheap using the cloud to store big, massive amounts of data. So most companies have moved to an ELT version where we extract our data. So we have our raw data. We load that onto a database. And then from that, we can, pull, either duplicate that database and then pull and process and say, I only want certain things, or put in a Databricks or something of that nature. Any questions on that? ELT versus ETL. Does that make sense? Okay, David just scared me. Cool. Wonderful. Hope this is making sense. Then we get to data processing. Now there's 2 types of data processing, which means we have this data and what are we doing with it? First, there's batch processing. So newly arriving data elements are collected into a group, and then the whole group is then processed at a future time as a batch. So instead of doing everything as it comes, you sort of wait and say, okay, I'm going to put all of these in a group. And then maybe at midnight is when I'm going to process all these different pieces of data or different things I need to do, these different tasks. So group is process can be determined in a number of ways. So I can do schedule time, whether it's amount of data or trigger some other event. So you can sort of think about it this way: when your stack schedules get unlocked, us as instructors go and unlock your schedule, but they don't unlock until midnight that night, right? Every time at midnight, we are unlocking and basically processing all of the unlocks. Our program processes all of the unlocks, and then, then it's done. And that can be really, really integral to saving money and time, because now I'm not having this constant flow of needing a server or computer to be running and process these different things each time I send a request. I only need it for maybe 10 minutes as long as that happens, and I can shut down that server. So it's a way that I can save time and save money. Another way is maybe I say, okay, once 100 requests of student stack transitions come in, once the 100th one comes in, I want to go ahead and process that. I can do that, or I can have a trigger of some other event. So like 3 days before, 3 days before a stack starts, maybe I want to say like 72 hours before, anybody that is in this one, I want to go ahead and push them through, something of that nature. I just gave you a bunch of examples. Sorry. Now there's something called a streaming process. And that is when newly arriving data elements are processed when it arrives. So in real time, the data is handled. Data is processed as individual pieces, and beneficial in most scenarios where new and dynamic data is generated on a continual basis. Can anybody think of an example of maybe a streaming process that'd be really important? Why you would maybe need data immediately versus it being like midnight? Stocks, maybe. David, I would actually say that most bank info is batch processed. So if you look, you might have like a pending in your, if I were to go to like my Wells Fargo account, I would have a pending, right? So it indicates that there is something, but it's not processed until typically midnight. They do batch processing. No, great idea though. One example of streaming processing is maybe a heart rate monitor. If we're going to the hospital, I don't want to wait. I don't want to set it up to where it's every 5 minutes I'm getting a heart rate, right? Like if somebody's in the hospital, their heart could stop. And if it stops at five, at the first second of my 5-minute countdown, their heart's can be stopped for 5 minutes before I even know, because it's batch process. So that's where streaming processing is like, I always want this data. I always want to know, and I always want to be processing and seeing like, yep, this is, I'm getting this new bit. I have their heart rate. I'm going to process and visualize that and show it on the machine, like beep, 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 because I want to make sure that all these levels or all these certain things, right? A hospital, I think, is a really great example of streaming processing. Is I need that in real time. I cannot have that information batch processed. It has to be immediately as I get a new piece of information. If somebody's oxygen levels are lowering or if their heart rate is dropping drastically, I need that immediately. I don't even have time to wait every 15 seconds, right? I need that as soon as I get it. That's the idea behind streaming processing. Any questions on streaming versus batch processing? Cool, we're cruising today. Now, there is going to be a piece when it comes to this exam that it's going to have you sort of have questions on sort of data jobs and different things. So when that, with that, I do want to go over a couple of the jobs you can get as like a data person. So there's data engineers, data administrators, and data analysts. Data administrators are people who actually manage databases. So they assign permissions to users. They go into the cloud and they store backup copies of data and restore data in case of any failures. So they're really like, you can think of system administrators for a company that handles like the application on the cloud and who has access. Database administrators do that, but with data in their databases. Data engineers are the ones who are actually working with the data and applying data cleaning routines, whether it's, taking in data, applying some sort of transformation, identifying business rules, and turning data into useful information. So again, maybe I want to track sales or something of the last quarter. My data engineers are working with that data, cleaning that data, and turning it into something that I can then use in the future. And people who typically use that are data analysts. And that's where they explore and analyze data. So they get this clean data, they have data, and they create visualizations and charts to visually show trends or different pieces of information that helps organizations make informed decisions. So for our database administrator, there are tools, and this is part of it. So I have to show you this part of the sort of the certification process. There are tools for database administrators in Azure, and for our database admin is going to be Azure Data Studio, because it provides a GUI, so a graphical user interface for managing different types of database systems. So Azure Data Studio, that's just sort of a memorization thing for database administrator. They can also use a SQL Server Management Studio, and it makes it very, very simple to back up or generate scripts or maintain and support operations on your database. It's as easy as really right-clicking on a database. Here, you've got this right click, you go to the tasks and you want to back it up, you click that and it backs up. So it sort of sets that up. It's a really, really great tool for dealing with that. Now with the database engineer, there's a couple of different tools you can use. You can use SQL, right? Which many database management systems provide tools that enable you to create and run SQL scripts. So like the SQL Server Management Studio, which is what we just talked about right here. Those let you create query tables visually, but you can also create your own SQL scripts manually. So if I did want to have a specific query, or if my company was interested in finding out certain things about my data, I can do that. I can use the command line. So it's just like a command line interface that supports operations. So I can use the like SQL CMD utility to connect to Microsoft SQL Server and Azure SQL database and run ad hoc queries and commands. So basically it's a way that I can go in and actually physically via my command line write in SQL queries. And then lastly, there's Azure Databricks and HD Insight. And so those help generate and test predictive models. So if I'm wanting to do any sort of like predictive modeling or any sort of machine learning pieces, I can use those to manipulate and query the data. And you can use languages like HiveQL or Python. So if you took our data science, we use Python. Python's sort of the king for data science, but it allows you to make predictive models and say, oh, I'm predicting sales are going to be, X next quarter using this bit of information. And then lastly, the big hitter for data analysts is Power BI. And that's a collection of software services, apps, and connectors that work together to turn your unrelated data sources or unrelated sources of data into coherent, visual, immersive, and interactive insights. So my data engineer gets my data, right? Gives me my data. And then I, as a data analyst, my job is to make it visually understandable, right? To where I'm not looking at rows and columns or pieces of information. I'm visually showing to show trends within my company, to show this year versus last year sales, to show sales per square foot, this year sales, to show where that's locating. I can use Power BI to visually see and show all of this information. When I'm dealing with data visualization, there's a couple different types we can do. We can do bar and column charts. So bar and column charts enable you to see how a set of variables changes across different categories. So for example, the first chart below shows how sales for a pair of fictitious retailers vary between sites. So this again shows you visually, instead of you trying to calculate all the numbers or just seeing the numbers, you're able to see, okay, each retailer is doing better at the out of town store. So the town center store actually is operating worse by volume sales than the out of town store. So if you're looking, where am I going to allocate my resources for retailer B or retailer A, I might look at the one that is predominantly doing the most volume. A line chart's going to be great for overall shape of an entire series of values over time. This is going to be really big with like financials. So stocks, somebody said stocks earlier. This is a great thing to show financials. Any sort of financial information is great with a line chart because you can see trends. If it spikes, if it dips, if you make X amount of money, you can do that over months or over days, or over hours. You can see sort of all of that with a line chart. Again, stocks is a really big one that visually I might not, if I see a bunch of prices, it doesn't really do much for me. But if I put it in a line chart, I'm like, oh, it's trending down. That's not great. Or it's trending up. Okay, that's awesome. So you can see those trends versus looking at specific numbers and being like, okay, it's high here, low, low, it's a little bit higher, low, high, like it can get a little bit confusing versus visualizing it really helps tell the story of the data. There are things like a matrix. So that's a tabular structure that summarizes data. So let's say I wanted just to get the entire revenue per quarter for each year. I can do that using something like a matrix, and it does rows, columns, and cells. And the matrix can cross-highlight other visuals on a report page. So if I wanted just the 2016 stuff, I can do that. If I just want a Q1 or Q2, I can do that as well. So matrix really just allows us, especially big with financials, it allows us to visualize and see a lot of this, a lot of these like financial pieces. Now, this is an interesting piece of data visualization. It's called a key influencer. And that's a chart that displays the major contributors to a selected result or value. So key influencers are a great choice to help you understand the factors that influence a key metric. For example, what influences customers to place a second order on why sales were so high, or why sales were so high last year. So it might be a way that, okay, you were seeing a massive spike in June for sales, and might say, why is that the case? Well, maybe it's because you ran a promotion, or you had an offer, or there was your biggest competitor went bankrupt or had a really big issue So it's a way that can maybe give some vision of why did this happen. That's where key influencers piece visualization can come in. And then there's this idea behind, I mean, I'm sure you guys have all seen like a pie chart, but data scientists actually and data analysts actually hate a pie chart because it's actually really hard to visualize and see the differences in scope, in the sense of, the pie, the circle, it's really difficult to see like in comparison how large something is. If it's, 3/4 of it or, one, it's just hard to like comprehend the size in comparison. But what data analysts really love is a tree map. And so those are, it's just easier from a rectangular standpoint versus a circle for our brains to comprehend. And so it just represents relative value of each item. So it can be like a hierarchical or with rectangles nested within main rectangles. So here we've got a count of product by category and manufacturer. So here we've got a category of urban and then all the manufacturers within there. And this one you can visually see, oh, urban is much, much, much higher than youth, which is a little bit smaller than mix, which is smaller than rural, which is smaller than urban. So it's just an easier thing to visualize versus something like a pie chart. Scatter plots show relationship between two numerical values. So a bubble chart is a scatter chart that replaces data points with bubbles. So this is a great thing for, if I'm wanting to compare two different things or seeing where they lie on sort of data points, I can use that or a bubble chart to show those. And it can represent an additional third data dimension if I need, with the bubble size. If I'm wanting to say how many were like this or how many was there, maybe my bubble size is higher. It's great for like a sales piece. If I'm wanting to know where geographically sales are really sort of, higher, I can use something like this to show the greater region, and the bigger the circle, the larger my sales or my reach is in that. Lastly, of my data visualization types is a filled map. Now, this one's really popular when it comes to like geographical data. You can sort of think about it at the beginning of COVID. It was showing you like cases and like how many people, like the case rate or vaccination rate or whatever that is. And a lot of visualizations you would see would be different colors of states. So like the more blue it was, the better it was doing. The more like orange or red it was a little bit worse that it was doing. There was a little bit higher, COVID rates, et cetera, et cetera. So a filled map is a great way. If we're looking at a geographical reference or comparison, we can use that as well. Now, just note that it is important from a data analyst perspective to use the right colors. Typically green and orange or red, is not a great thing because there is a combination of the two that people have a hard time distinguishing, like a colorblind piece. And so you do want to make sure you are, intentional with what colors. Typically like blue and orange is a great combination that most of the population can see. Even if they are colorblind, it's not as common with blue and orange as it is with green and red. But this comes from Microsoft itself, so we put it there. The whole story behind data analytics, we're almost to a break, guys. You guys are crushed it. Whole story behind data analytics is there's a couple pieces. We've got descriptive analytics, which is trying to say, okay, we have the data, what happened? That's what we call descriptive analytics. Then we've got, and that's maybe our bar chart of sales, or I'm wanting to look at my financial sales of last quarter. I can use something like a line chart to do some sort of descriptive analytics. Why did this happen? That's where that key influences piece comes, like what caused this spike or drop in sales. I can do predictive analytics, which is, okay, what am I forecasting next quarter's sales to be? And then I can do prescriptive analytics, which is, okay, well, what should we do? Where do we go? And that can really be, now we have prescriptive analytics really is tied with cognitive analytics. And so that's where we can create some sort of self-learning feedback loop or machine learning to help us understand what might happen if circumstances change and how we might handle those situations. And by using these machine learning models and saying, yeah, if we do the sale here, it might spike numbers, right? Or it might spike sales. That helps us with our prescriptive analytics, right? And say, okay, using cognitive analytics, what would happen if we changed this one piece? So utilizing predictive analytics. And then it helps us say, okay, if we did do a 10% off sale or we do a surprise sale, that might increase revenue. So that's what we should do. So you can see how they could all come together. Okay. Any questions? Any questions at all? Anybody still there? Okay, perfect. Okay, well, we're going to take a 15-minute break. All right, friends, does any group want to go first? Any group specifically want to go first?
I can go for small business.
Perfect. Thanks, Riley.
So yeah, we felt there was a bit of a consensus between the three of us, and David and Natasha, feel free to chime in if you have any other thoughts, but we felt like since we were going with a small business and our needs would probably fluctuate throughout, the particular month, depending on, when inventory is being taken and stuff like that, we felt like the elastic pool would probably be best suited to us, and working with a little bit, less resources, that it would probably be best fit to go with like the elastic pool in a single server.
Okay. Yeah. From an example of an infrastructure as a service, a platform as a service, and a software as a service, what would you say that your company would use?
That would probably be more of, we want to do platform as a service, I think, because full applications, that might be useful, unless we really wanted to customize how our interface is laid out.
Sure.
So maybe software as a service, but platform as a service would be my guess. David and Natasha, if you have any other thoughts, that's just me.
No, I agree with that, because the Azure SQL databases is under the platform as a service umbrella.
Yeah.
But just then having them handle all the database administration and security and all that of the databases. So
totally. Yeah. And I think with the small business, it's important to remember is and this is sort of a general understanding, right? Businesses can vary. So let's say that your entire business is like, you're like a database consultant, and that's what you specialize in. There is a use case for maybe having an infrastructure as a service, because you're like, I want to build everything because that's literally what we do. On the other side, you could have a coffee shop that's a small business that wants to have an application and wants to have a database of all their customers to have like a loyalty program, but they have no technical experience, right? That's where software as a service can come in. I think you guys are dead on with the platform as a service. It's a great medium ground. If you did want to host applications or apps, you might use that software as a service, and you also get different things with Office 365. But I think exactly what you guys are saying for right now, with the prompt of you want to build something from the ground up, platform as a service is also a key one. So just knowing that every single company, to an extent, every single version, whether it's medium, large, and software, could implement sort of all three of these. Now, really the only one would be a large business might be less likely to do software as a service, but it can be both. So great job, guys. Thanks for sharing that. Medium business, do you guys want to go?
Sure. We talked about it, if you don't want us to go. So we talked about as a medium business, because it said on here that we already have an on-site database, but we wanted to migrate it to the cloud.
Yeah.
But specifically, it says on it, we don't have a very large team for maintenance. So we're talking about, we ruled out SaaS because we already have our own database out there.
Okay.
You're talking about the idea of infrastructure as a service or platform as a service. We went more with platform service specifically because it says on there on our directions that we don't have a large team for maintenance. So being that a platform as a service, generally the Azure databases, they implement the databases and they do the security for you and they do the configuration for you. We went more with platform as a service specifically for that. So since we did that, we looked more into it and we looked at the Azure SQL database managed instance. You know, we're thinking on that because it's talked about it. You're able to lift and shift on-site SQL server instance from a database and train and move it more to the cloud. But then we took a poll of the three of us, and having come from the Coding Dojo online, we were more thought of MySQL databases and the MongoDB SQL, NoSQL databases. So we decided on we looked more and we saw that Azure database for MySQL, which is, as far as we understood, is also a PaaS. And under that, we saw that there was the Azure database migration service, would allow us to migrate our online database, our on-site databases to a Azure database instance.
Yeah.
So that's what we're thinking.
No, I think that's exactly right. And I'm glad you guys caught that, because that's what's on the exam a lot. On the certification exam is a lot of little things like this, but you don't have a large team available for maintenance. You know, if they would have come on the other side, 1 second. If they would have come on the other side and said, you know, but you have a team large enough to maintain this, just that little difference could lean from an infrastructure as a service to a platform as a service. So I do think exactly like what you guys said, having this, not having a large team for maintenance does tell me that, yeah, platform as a service is great because the maintenance is already maintained, right? It comes with it. So you don't have to do that. You don't have to have a team. Infrastructure as a service is great, and it gives you a lot of flexibility, but you do have to have people that can, you know, update operating systems. That relies on you. Any sort of development tools, database backups, business analytics, all that has to do, you know, you have to do that yourself. And so it does make a larger team. You do have to have a larger team to sort of build out some of that stuff versus having a platform as a service, which does it for you. Now, infrastructure as a service does provide flexibility. So maybe you don't want Power BI for analytics. You do want to do something else. Okay, maybe infrastructure as a service makes sense. But I think for what you guys are saying, platform as a service is great. And I do love the fact that you guys pointed out that the managed instances, right, or the instance service does allow you to transfer your data on premise. It's just a very quick and easy sort of service that allows you to take something on premise, which means you have your own servers, you have a database on your building premises is what it's on premise means. Like you have your own servers, takes that and transfer that data to the cloud really, really easily. So great job, guys. And wrapping it up would be our large business.
Yeah, let me show my screen. All right, for a large business, they wanted a full like OS control and more configuration options. So kind of had to go with this infrastructure as a service using virtual machines. It's pretty much like having an on-premise database, but the hardware isn't managed by you. The hardware is somewhere else.
Yeah.
And yeah, no, that's pretty much it. Not too much.
Yeah. I think that's exactly right. And just sort of pointing out this idea of a virtual machine is just like what you said. It's like having a computer that you can use and borrow, but Microsoft is the one who manages the computer, right? So you don't have to manage anything. Microsoft does that for you. And even what's great about it is if this computer is 3 years old, let's say you're with the company for 3 years, Microsoft is the one who upgrades that and makes it better, right? In whatever way, faster or better chips or whatever the process is. So when you do have this virtual machine, it's just basically saying, I don't have to have the upfront cost of having my own server. Microsoft does that. And when we think about sort of capital expenditure, which is sort of an upfront accounting cost of handling and having business, for dealing with our servers, it's not just the servers we have to have. We have to have somebody who sets up the network, somebody who sets up the servers and server racks. We have to have cooling because your AC has to be working so they don't overheat. You have to also deal with security, right? If somebody steals that server, you have a bunch of costs associated with having your own on-premise servers compared to all the liability is on Microsoft. And if you have your own on-premise servers, let's say some sort of disaster happens and some sort of natural disaster and your building gets flooded, well, you're down until you can get more servers up and running, or hopefully you have a backup. And, or you have, you have to get servers back up and running. You have to buy new servers, set them up, do all that. Versus with the cloud, you can just do backups in literally other parts of the world. So maybe you have a server on the Eastern, it's called US East on Azure, and you have a backup on US West. So if something were to happen on US East, well, okay, that's literally another part of the nation that seemingly will hopefully be unconnected from that. And so that's the idea behind these virtual machines. And exactly like what you said, if you want, again, I'm glad you guys caught that sentence of you want to maintain full OS level control. The only way to do that is through doing an infrastructure as a service. So great job, guys. Are there any questions on this stuff? Cool. Well, then all we have next is lunch. So we're a little bit early. Let me stop the recording.